All right, in this video, we're going over standard form of a quadratic function, part 2. All right, there's no new vocab for this, so let's get right on into it. All right, converting standard form to vertex form. All right, if you remember from the last video, standard form is f of x or y equals ax squared plus bx plus c. And if you remember, vertex form is f of x or y equals a x minus h squared plus k, where h and k are the x and y coordinates of the vertices, of the vertex, because there's only one. All right, so if we look here, to change y equals 2x squared plus 10x plus 7 from standard form into vertex form, we need to do two things first. First, we need to identify a and b. We need to identify a and b. So a in this case equals 2 and b equals 10, because remember, it's just the coefficient. You don't take the variable with you. It's just the coefficient. All right, now, so the x coordinate of our vertex, all right, if you remember last night's video, the x coordinate of our vertex is simply going to be negative b divided by 2a. All right, negative b over 2a, so we just plug that in. Negative b we know is 10, a is 2, so 10 over 2 times 2, which gives us negative 10 over 4, which reduces down to negative 5 over 2. All right, so we know the x coordinate of our vertex. I'm going to write that down here. Vertex is negative 5 halves. Now we just have to find our b value. Our k value, which is the y coordinate of our vertex. Well, all we simply do there is go f of negative 5 halves, which is the x coordinate of our vertex. So we're just simply going to plug that in. 2 times negative 5 halves squared plus 10 times negative 5 halves plus 7. Now, when you square a fraction, you square the top and the bottom individually. So this is going to be 2 times 25 over 4 plus, now when you multiply a whole number by a fraction, you just multiply by the top. All right, so it's going to be 10 times 5, which is 50. And since this is negative, it's going to be minus 50 over 2. And then plus 7. All right, plus 7. Now, this here, 2 times 25 over 4, the 2 and the 4 will cancel. This will go to a 1, and this will go to a 2, leaving us with 25 over 2 minus 50 over 2 plus 7. Now, the 7, our common denominator, because that's really 7 over 1, our common denominator is 2. So 1 times 2 is 2. So 7 times 2 is 14. 25 minus 50 is negative 25 plus 14 would be negative 11 over 2. Negative 11 over 2. All right, so that is the y value of our vertex is negative 11 over 2, and our x value is negative 5 over 2. All right, so now we know what a is. All right, we know what a is. It's right here. A is 2. We know what h is because we just found it here, and we know what k is because, again, we just found it here. So now all we have to do is come back up here and plug it all in. F of x or y, they're both interchangeable. F of x or y, they're completely interchangeable. All right, a, which is 2, x minus h, well, h is a negative 5 halves, so it's going to be plus 5 halves squared, and then minus 11 over 2. All right, so what is vertex form of y equals 2x squared plus 10x plus 7? Well, it is simply y, or f of x, because like I said, they're interchangeable, equals 2 parentheses x plus 5 halves squared minus 11 over 2. All right, so basically all we're doing here is we're using what we did in the last video to find our vertex and to identify A and B. And once we have identified A and B in our vertex, we have our 3 variables that we need for vertex form. So you just simply, after you find them, you just simply plug them into vertex form and you come up with your equation. All right. All right, here's what I want you to try. What is vertex form of y equals negative x squared plus 4x minus 5? Go ahead and pause the video and figure this out. All right, so first thing, let's write down both of them. We have y or f of x, because like I said, they're interchangeable. Ax squared plus bx plus c. And vertex form is y equals a x minus h squared plus k. All right, so the first thing we need to do is identify a and b. So a equals, we have negative x squared. Well, there's no number here. Well, remember, when there's no number in front of a variable, there's an understood 1. So a is negative 1, and then b is simply 4. So now, next thing we need to do is find our vertex. Remember, to find the x-coordinate of our vertex, it is simply negative b over 2 times a. So negative b, which is 4, over 2 times a, which is negative 1. So this is going to give us negative 4 over negative 2. The negatives change to a positive, and 4 divided by 2 is 2. All right. Now, all we have to do is take this 2 and plug it into our equation. So y equals negative 2 squared plus 4 times 2 minus 5. 2 squared is 4 times negative is negative 4. 4 times 2 is 8. And then minus 5. Well, negative 4 plus 8 is 4. Minus 5 is negative 1. So our y value is now negative 1. So now we have a and b. We have our vertex. So you simply just plug it into here. So our final vertex form of that equation is simply y equals, bring the a over, so negative 1, or you can just say negative, x plus 2, minus 2, let me rewrite that, x minus 2 squared minus 1. All right, so once you find a and b, and you find your vertex, remember you just plug those variables back up here for x, h, and k, and you simply get your final answer, which takes standard form and converts it into vertex form. All right, let's move on. Interpreting a quadratic graph. All right, so the New River Gorge Bridge in West Virginia is the world's largest steel single arch bridge. You can model the arch with the function of y equals negative 0.000498x squared plus 0.847x. What are x and y in feet? And how high above the river is the arch? Also, how long is the section of bridge above the arch? All right, so the first thing we need to do here, step 1, we need to find the vertex. Remember, the vertex is negative b over 2a. This one's going to look kind of ugly, but this is what we have to do. All right, so b is a negative 0.847 over 2 times a, which is negative 0.000498. All right, this you would just punch into your calculator, and it would give you about 850. All right, there'll be a little bit of a decimal, but it'll be about 850. All right, so our vertex x-coordinate is going to be 850. Now, remember, to find the y value of the vertex, you simply take your x value and you plug it into this. All right. So we're going to have y equals negative 0.000498 times 850 squared plus 0.847 times 850. All right. Again, plug that in your calculator because I don't expect you to do that by hand. And you should get out about 360. All right. I know there's going to be a decimal, but for the sake of this, since the decimal is going to be so, since we're, well, let me rephrase that. Since we're talking about a bridge and the decimal is not really going to make that much of a difference, for the sake of this problem, we're just going to leave it out, okay? Because the decimal is only 0.145 for this, so we're just going to leave that out and round to 360. Same thing here. We're just going to round it to 850 and leave it alone from there, all right? So what did we do? We did negative b over 2a to find the x-coordinate. And once we found the x-coordinate, we plugged that back into our function to find our y-coordinate. All right, we plugged that back in to find our y-coordinate. Now, what does this mean? All right, well, if this was on a graph, okay, if this, let me change colors. Hopefully we can see this. If this was on a graph, like so, this is terrible. With this being the origin right here. All right. What that tells us here, our vertex is 850, 360. Okay, which means from here to here, it is 300, no, I'm sorry, it is 850 units, or in this case, 850 feet. Okay, which also means from the center point to the end over here is also another 850 feet, right? Because this is our axis of symmetry through our vertex. So the distance from the origin to our axis of symmetry and the distance from our axis of symmetry to the other side here, which is where our parabola crosses the x-axis, it's going to be the same length. So they're both 850 feet. So how long is the section of bridge above the arch? Well, it's simply 850 plus 850, which is 1,700 feet. All right, so that answers the second part of the question here. The length of the bridge above the arch here is 750 feet because you're just going to take the x-coordinate of your vertex and double it because from the origin here to your axis of symmetry and then from your axis of symmetry to where you cross the x-axis again is going to be the same distance. All right, so 850 times 2, 750 feet. Now, how high above the river is the arch? Well, we know looking at this, the height from if we, like I said, if we made this into a graph, the height from the x-axis to the top of the bridge here, or to the top of this arch here, is 360 feet, right? Because that's our vertex. That's the y value of our vertex, which is 360 feet. Now, this wants to know how high above the river is the arch. Well, if the arch is 360 feet from this point to this point, and this point down to the river is 516 feet, the total height above the river is simply going to be 516 feet plus 360 feet, okay, which gives us a total of 876 feet, all right, because remember, again, if we put this on a graph, all right, from the x-axis to the top of our arch here is 360 feet, but from the x-axis down to the river is another 516 feet. So we have to add these two together to get the total height of the arch above the river. All right, so the total height of the arch above the river is going to be 876 feet. Okay, so we still did what we already knew how to do. We found our vertex using negative b over 2a. Once we found that value, we plugged it back into our equation and found our y value of our vertex, So we have our vertex right there. Then we just ask, well, what does all that mean in relationship to this problem? Well, after we find that vertex, what it means in relationship to the problem is, again, if we were to put this on a graph from 0, 0 to the straight over to the x-coordinate of our vertex is going to be 850 feet. Well, from our vertex to where we cross the x-axis again is also going to be another 850 feet. So the total length of the bridge above our arch section here is simply going to be 850 feet plus 850 feet, which is 1,700 feet. All right. And also the height from our x-axis to the top of our arch is simply the y value of our vertex. So that's 360 feet. But we want to know how high the arch is above the river. And from the x-axis, again, like I said, if we had this on a graph, from the x-axis down to the river is 516 feet. And then we know from this point to the top of the arch is another 360 feet. So you're simply going to add those two together to get the 876 feet that the bridge is above the river. Okay? So this is how you can take this and convert it to a real world problem. All right? So that's it for part 2 of standard form of a quadratic function. Feel free to watch this video as many times as you need to, and make sure you come tomorrow ready to work some problems. See you tomorrow.